Okay, so the first one, you tell me if you have any questions.
Right.
Okay, now, I'll gladly walk through these with you. So, and for you guys that weren't here, start with what they first give you. They give you your vertices at 0, 2, and at 0, negative 2. So, right away, which way is my hyperbola going to open? Up and down, right? This way. So, which is my major axis? The y. So, I'm going to start this way. And my A always has to come first in a hyperbola. So now, I start filling in what I can based on this piece. The vertices should give me A, letter A. It's the distance from the center to the vertex point. But we didn't get a center. So, since the vertices are equal distance from the center, can I find the midpoint? Good luck. So what would be the midpoint? 0, 0. So therefore, 0, 0. Now can I tell the distance from the center to my vertex? 2. So A is 2. Okay, so A, I can even fill this guy in. So I'm getting there. It looks like all I need is B.
And so your C is 4.
So your C tells me your both sides should come up here, down here, and it's the distance from here to here, which Monet just said 4.
And you have to do C squared equals A squared plus B squared.
Good, because there's the only thing that will get me my B squared is my formula C squared equals A squared plus B squared. Now, you don't have to go all the way down to B. All you have to go down to is B squared. So C squared equals A squared plus B squared. C is 4, so 16. A is 2, so 4. All I need is a B squared. Subtract 4, and 12 is B squared. I just need to replace this with 12. I don't need to find my B because I'm going to have to square it again to put it in my equation. When they ask for the equation, I don't need for your asymptotes. I don't need for all those pieces there or what your points are. I just need you to get me the equation. So when I rewrite this, y squared over 4 minus x squared over 12 equals 1. Usually I find if we find the equations, it starts to make the whole process make sense a little bit better. Did you find the sheets?
No, I didn't. It wasn't up there.
No, good. Okay, I'll have to look. I'm sorry. All right. So are we good with this? Okay. Let's try another one. So I'm given my vertices at 1, 0 and negative 1, 0. So which way is my hyperbola opening up? To the side. Okay? Now my distance from my vertex to my center. Oops, I don't have a center. What's midpoint between negative 1 and positive 1? 0. Good. No, if this is negative 1, 0, and this is positive 1, 0, what's the midpoint? The midpoint is the averages of the x's. Negative 1 plus 1 divided by 2, 0, and 0. There's my center. So I know my x comes first. I start like this. So I know 0, 0. The distance from here to here, 1. A is 1. Again, I need B. Now, they gave me my asymptotes. My asymptote is a line that goes like this. It helps me graph my little 2 parabolas there to make my hyperbola. Now, what's going to help me is this piece right here, is my slope. My slope is change in y over change in x. So I go down here, I find my y, I look underneath, I take the square root. That's B. I find my x, I go over here, I come down, B is under this part, my x is, square root of 1 is 1. So now, I need to find this. My slope is equal to 5 over 1. Cross multiply. There's B, 5. So I plug in the B, up, and I got to square it. So I rewrite my equation, and if you want to keep it over 1, keep it over 1. Your slope, when we found your asymptotes, we used your slope to get there. We said change in y over change in x. We went to the y, and we saw the square root underneath it. So use that same concept, but backwards this time. 35 was the hard one. Did you guys get 35? Is that the one you showed me, Manny? 35? Okay. I have to look at his again because I think he was on the right track. I think your uncle was on the right track. 35 was the hard one. So I have my foci here and here. I know which way is my hyperbola open. Up and down. Not at my foci though, at my vertex. At my vertex. My vertex I don't know yet. But I can find my center by taking the average. And again, my center was at 0, 0. So I know my y comes first. I know my center, 0, 0. Okay. What does the foci give me? What letter? C. So I know C is 8. Okay. Now, I'm given an asymptote. And I know this is my slope. Okay. So here's my problem. I look under y. I don't have a number there. I just know that it's the square root of a. I look under under x, and I see it's the b. I don't have a number, but it's the square root of the b squared. So right now, I'm looking at this. So I cross multiply, and I get 4b is equal to a. Not looking too good. However, I do know c. Hang there with me. I do know c. And what is the value of c? 8. God bless you. And I know that a is equal to what? 4b. So I can replace this. Can I just substitute that in? Like a little systems of equations thing, kind of? So 64. I got to multiply it. I got to square the 4 as well. So 17b squared is equal to 64. And b squared is equal to 64 over 17. Okay. Now, for my b squared, that's all I have to put in here. You have a couple of ways to find your a squared. You can take your b squared here. I would have to take the square root of this guy. And find a. So this is going to be 32 over the square root of 17. When you square this to put it in here, this becomes 1024 over 17. And again, we can't leave those fractions in the denominator, so we flip them to the top. This is not going to be on the test, this one, but I need you to know how to do this. Because it's just a process that we're following. It looks horrible, I get it, but if you can follow the process, you can actually see this. And even Manny's uncle helped him. He found the process, right? Because this is what he got, isn't it? It was this. I couldn't remember what the answer was until it came up here. I knew they had weird numbers in there, but I couldn't remember. But look at your process. I find the same thing. Whether they give me numbers under my x and y, whether they give me letters under my x and y, it's the same process. And then maybe something will catch my eye, and I'll say, well, I know C, so I can always replace A with a B, and then have one equation, one variable. Okay? And the last thing you're going to do is flip this over. When you see keep, change, flip, this is this times this over this. So it causes it to flip over. It just causes it to flip. You can't leave a fraction in a denominator of a fraction. That's the one thing we won't allow. No decimals in that fraction, no fractions within a fraction. Radicals, we allow radicals in our denominators. We don't have to rationalize. We have to simplify everything, but we don't have to rationalize. That's the only thing we get away with in pre-calc that's a little bit different than your algebra 2. And I think the new Common Core algebra 2, you don't have to rationalize your radicals in the denominator anymore. So back to the nicer ones. I'm given a vertex of 2, 0. So I come here and I write my 2, 0 and I write my 6, 0. Okay? Somewhere smack in the middle is my center. So how do I find the midpoint? The average of my x's, the average of my y's. So 8 divided by 2 would be 4. And does that look like it's smack in the middle? 2, 4, 6? Right?
Yeah.
Yes.
Why do you put 4?
4?
No, and when you did x minus 4 to over 4. Shouldn't that be 16? Since a squared is supposed to be on the
Well,
bottom?
what's the distance from A? What's A? Now, if you look at this, from 4 to 6, what's the distance here? 2. So A is 2,
Okay, sorry.
right?
Looking at the
No, you're fine. You're just a little bit ahead of me. So we found A to be 2. Now, so we know it's an x squared first. We know this is 2 squared. We know this is B. Okay, so far so good. We know this is 4 and 0. We're good here. All we need to find is B. So now we get the C. Good. So the both sides said come out here. So the distance from here to here now, from 4 to 8, is 4. That will help me find B. No different than that last one when we just did, when we used the C. We had to find the B. We just had to replace the A in terms of B. So we got there. Now, you only need to come out to B squared. Just put your B squared in for this guy. So we're getting x minus 4 squared over 4 minus, there's no 0, no y, and there's no y and k there, so it's just the y squared, over 12 equals 1. You can find me B, but I don't need B. I just need B squared. Can we do this?
Those are the easy ones.
These are the easy ones. But the thing is, you should apply the same concept when you hit a hard one.
I just don't know what to do with like asymptotes and stuff.
The asymptotes. Well, the asymptotes, the one thing, if you look at that formula sheet that I gave you, the asymptote says this.
A formula sheet.
Well, that first day with the notes on it, with the asymptotes,
There's more.
yes,
Are both ellipses and hyperbolas going to be in the test?
ellipses and hyperbolas, that's it. You did your parabola stuff.
I think we're going to get confused between when the equation is like the c squared and the plus and minus.
It is, but give me a second to get over this thought, and I will hit your thought in a second.
Sorry. How did you get -4 for the x on this?
To the center.
Because the center is between 2, 0, and 6, 0. You want the midpoint, average them.
Oh, I see. Oh, yeah.
Okay, now, you're saying the asymptotes are confusing, but look, your original equation, guys. Remember when I told you, what is this? The change in y over the change in x. Slope. That's how you get this. Slope. The change in y over the change in x. So whenever we have the change in y, we go down with under y, we take the square root of the y denominator. We take the square root of the x denominator. This is my slope. That's what's going to go in here. This, yes, I'm going to have to reduce this, so therefore I can reduce this down. But this is how I get my asymptotes equation. So all we're doing is just reversing that process. Okay, slope is what you've learned for the two asymptotes are linear. So slope is what you learned using your linear equations for years now. Okay? Getting back to what Hetzel said. Look up here for 1 second. Here's my ellipse. I've got, let's write the equation of this ellipse. It's at the 0, 0. Which one's longer, the x or the y? So say this goes to 5, 0. What would I put under my y? 5 squared, good. What would, if this went to 2, 0, what would I put under my x? 2 squared. Okay. Where do I find my foci? On the major axis, in between. Okay. What is the length of my major axis? I'm sorry, let me rephrase that. From my center to my vertex, what is my length there? 5. What is my length? Well, let's say this is at 0. Oh, this is at 0, 5. Sorry. Say this is at 0, 4. What's the length of my C? 4. Isn't my C smaller than my A? So shouldn't I be subtracting to get there? So if I did this, won't I have to subtract A to get there, to get to B? I want it to be inside. I'm going to take B and subtract whatever this area is to get there. Obviously, I made a mistake with those, but if I said, for instance, I just wanted to show you that. God bless you. Now, if I took the same thing and I made a hyperbola out of this, we made this a box, right? And we did this, and we said, well, your major axis is the one that comes first. It's going to go like this. Where do I want my foci? Outside. So now, don't I need that to be the greatest one? So shouldn't I be adding those two parts together, right? That's how you remember if you're adding or subtracting. If it's inside, you're subtracting. You want to keep it in there. If it's outside, you want to add to that. Otherwise, if I take A and I subtract B, I'm inside. If I take A and I add B, I'm outside. Make sense? That's like the major difference, because it's a minus in between. But the rest pretty much works the same. And what you have to remember on a subtract is it matters who comes first. Okay, so now, let's see if we can hit this one. So my vertices is at 4, 1 and 4, 9. So I know my parabola opens up and down. My center is smack in the middle of that. So I take the average, the midpoint. The average of the x's gives me 4. The average of the y's, 1 plus 9 divided by 2, gives me 5. There's my center. And who's my major axis? Who's going to come first? Y. So y minus 5 squared minus, and start just like this, x minus 4 squared equals 1 over, the A comes first, then the B. So start like that. Which letter can we find when we know our vertices? A. So what's A?
I thought that we went over this.
We went over this one?
Yeah.
Oh, we did this one class?
No.
Okay, we'll just do it again. So if this is 4, 5, and this is 4, 9, how many positions did I move up? 4. So A is 4. I got this guy. Okay, so I need B. But the focus points gives me what letter? C. And that's okay. I can use my foci. My foci is down here. 4, 0. Oh, so from here to 4, 0, how much did I go? 5. So my C is 5. And then I just have to use my formula and find B. And I found B. You can even find just B squared. You can do 25 equals 16 plus B squared. B squared is 9. And replace B squared with a 9. And then just rewrite it. One step at a time. Exhaust one piece of information. The vertices gives you the A. The covertices, which we don't really call covertices, but that'll give you the B. That's why you're not being given a covertice.
So you don't need to find a covertices sometimes, right?
Well, technically, when you're drawing your box, you need it because you need the rectangle. And you just needed to draw that box in there.
Does your hyperbola, like the vertex, I forgot, does it touch the vertex or just that's for the box reference?
It touches the vertex. The hyperbola itself, if this is where your box is, it comes off of this, it touches it, that's its vertex, and then it uses those asymptotes as a guideline. But to do the equation, we didn't need to put the box in there. Don't forget, this part was just finding the equations. Okay? Now, this one's a tough one. Anybody get this answer?
We said not to do these
Oh, I said not to do this?
Yeah.
Pass us through what this is.
Okay.
Told us not to do 41 or 47.
I told you not to do those. Okay. All right.
Can we put another asymptote one?
Yes.
That's
All right, so let's do this last one. Just ignore what I have there because we'll do it together. So let's do this, guys. So the first thing we're giving is a vertex. This is the one I said not to do. We'll do this together. I've got a 0, 2, and I've got a 6, 2. So if it helps, translate your axis right now. Where's the other one's going to come through? Smack in the middle, right? If this is my vertex, that means which way is my hyperbola going? Bless you. To the left and right. So which one is my transversal, my x or my y? My x. So I'm going to start like this. X minus h squared minus y minus k squared equals 1 over a squared, b squared. It matters who comes first in a subtract. Yes. So the center is 3, 2. So you take the average of the x's, 6 divided by 2, 3, the average of the y's. So my center right here is 3, 2. So now I can replace 3, 2. My goal is to eventually replace everything there, isn't it? So is there anything else I can tell when I know my center and I know my vertices? The A. So the distance from here to here is what? 3. So A is 3. So okay, come down here, 3 squared. So it's looking like all I need is a B. Now, it gives me 2 asymptotes. If I drew these asymptotes, they would be coming through this center, somewhere like this. One is a negative, one is a positive. We're going to use the positive right now. Use the positive whenever you can. That's my slope. So watch. Your slope is 2/3. Your slope is change in y over change in x. Go find me the y. What's underneath the y? So what's the square root of b squared? B. Find me the x. What's under the x? 9. What's the square root of 9? 3. So far I have this. 2/3 is equal to b over 3. What's b equal to? Well, if the denominators are the same, what's going to happen to my numerators? Don't they have to be the same? Cross multiply. 6 is equal to 3b divided by 3. b is equal to 2. These denominators were the same. So these have to be the same. So b is 2. 2 squared. Now I got my equation. It's slope. Change in y over change in x. So all you have to do to remember, though, is to make sure you take the square root. Because the asymptote formula said to take the square root. But I try to remember the square on the top, the square on the bottom. I need it all by itself. Take the square root. And then I just make it pretty. X minus 3 squared over 9 minus y minus 2 squared over 2 squared, which is 4, and I'm good. Not bad, right? Eh. Eh. I don't know, I guess I didn't record this. Oh, I am recording the sheets. I don't know where they are. Does everybody have this sheet?
Yeah.
You don't have the sheet? And it's not over here?
That one is over there.
That one is over there? Maybe do you have this? Everybody else have this? Connor, do you have it?
I can just write it down.
No, I need you to have the whole review.
No.
Not that no, you can't write it down, but I mean, you'll be writing down all of them then.
Well, I think it was the water.
Okay, that's what comes out again. It becomes mine.
Alright.
Alright, so let's see how we can identify this. So, first thing, what do you notice? How many squares do we have?
2.
2. So, can this be a parabola?
No.
Can't be a parabola, because a parabola only has one. So, it's either going to be the equation of an ellipse, the equation of a circle, or the equation of a hyperbola.
Bro, what did I miss? What you just said, like, I just.
We did the parabola already, right? So if there's only one x squared, then it's a parabola, or one y squared, then it's a parabola. But if it's a circle, and these all look the same, watch. This is the equation of a circle. If I expand this and have a different center, isn't this my circle? Isn't this the equation of your circle? Okay? So say I do this. X minus 1 squared plus y plus 2 squared equals 9. What's the center of this circle?
1 negative 2.
1 negative 2. Oh, I don't have to pick up a different color and I didn't have my color left. Alright, so now watch. We know this is a circle. What's my radius? 3. Okay, so it could also be an ellipse. Why could it also be an ellipse? Because of the plus. Doesn't this look like my ellipse? I just have to set this equal to 1. So I divide everybody by 9. So x minus 1 squared over 9 plus y plus 2 squared over 9 equals 1. We said a circle is a special kind of ellipse, isn't it? I could write it like this because a squared would be 3, b would be 3. Oh, it's a circle. But I could write it like an ellipse. So what tells me that this is a circle is the coefficient right here. If both of those coefficients are the same, it's a circle. If they're different, it's an ellipse. Agree? Because if I had this, if this said 18 and this said 1, they're not the same. So when I divide by 9, then my 18 would say, or I'd have to bring this down and make it a fraction, but would not be the same. They would that would be an ellipse. So my point is, we're going to still get everything to one side, your x squared and your y squared, because they all look the same. So since we know this is not a hyperbola, I'm sorry, not a parabola, we're going to bring this to this, and by bringing this, add it to the other side. So looking at this, I could say, it could be a circle, but what makes this not a circle when I first look at it? What do you see? No, I have a plus. I have a plus. A plus has a circle, but what's different? Your coefficients are different. If I divide everybody by 81, aren't they going to get me different denominators? Yeah. So therefore, what is this? Ellipse. ellipse and circle have a plus. Hyperbola has what? Minus. So I rule out, can't possibly be a circle. It's looking like it could be, but because these two are different, then I know it's an ellipse. It's got a plus. Circle and an ellipse both have a plus.
Wait, so on the test, where it says identify the shape of the graph of the equation, you mean it's right, ellipse, or...
Yeah, yeah, you make it look like, that's it.
So what?
So, this guy has an x squared and a y squared. So it obviously doesn't, it's not a parabola, so I can't leave it by itself. I'm going to pull this over to the other side. So I'm going to subtract 64y squared. Could this be a circle? It's a minus. It can't be a circle, it can't be an ellipse. What is it? Hyperbola. So therefore I need this equal to 1. I just divide everybody by 49. And I know they didn't work out right because I didn't want you to do any work with it. I just wanted you to identify it. So then I would make this equal to 1. And I got a hyperbola because that guy's a negative. Okay?
So that's really all we have to do.
Just all you have to do is identify. This guy, I'm going to add y squared to both sides. So I get x squared plus y squared equals 16. So this could be a circle or an ellipse. Which one is it? A circle. Because
Wait,
look,
what's the difference between a circle and an ellipse? Because all the coefficients.
coefficient. What are these coefficients? They're both 1.
Are they always 1 if it's a
No, we could start like this. And then say, okay, make it be 1. Divide everybody by 2.
But
This is your radius squared. As long as the coefficients are the same, it's a circle. So how about that last guy? What's that last guy? A circle. Now we're not going to say hyperbola because the x squared and the y squared are on opposite sides of the equal sign. You've got to get them to one side of the equal sign. Okay, so you worked on review 4 last night? Or did you work on it at all? The rest of it?
Yeah.
Okay. There's a couple of equations to do. But I want you to cross out the parabolas. Because we're not doing parabolas, we're only doing ellipses and hyperbolas. So cross out 2 and 3 out of this one.
2 and 3.
2 and 3. They're parabolas. 2 and 3. 2 and 3. 2 and 3 are parabolas. We're not going to do parabolas separate.
What's a conic?
A conic is this, ellipse, hyperbola.
Oh.
Oh, you're so smart, Hector. Why don't I Howard down?
He even switched his bracket.
Oh my God.
Ah.
2 and 3, right?
Howard.